Good afternoon, AP Physics. Who wants to analyze a complex circuit? That's right, you do. So, here I have a circuit for us. Let's talk about how do we analyze the circuit. Well, the first thing that we notice here is that we have a parallel component within our main series. So I want to take this and reduce it to a single resistor. So the way we add resistors in parallel is, of course, the reciprocal addition. So 1 over 40 plus 1 over 60 equals, I'm going to hit that into my calculator, 40 reciprocal plus 60 reciprocal equals, that gives me 0.042. But I have to remember that I need to take the reciprocal of that answer. So 0.042, take the reciprocal, and we get 24. So the two resistors combined give me a resistance of 24 ohms. So I really could redraw my circuit as a 24 ohm resistor in series with a 30 ohm resistor. And this is my 25 volt battery. Now I've got two resistors that are in series with each other. The way we add resistors in series to get our total resistance is we just add them. So 30 plus 24 gives me 54 ohms. And that is the total resistance of this circuit. Okay? Now that I know that, I can find out a few other things about the circuit. First of all, I know that my total resistance is 25 volts. That's the battery. So now I can figure out what my total current is. That's going to be V divided by R. So that would be 25 volts divided by 54 ohms. So we should get, when I hit that into my calculator, something a little less than half. And indeed I get 0.46. Which makes sense because when we are in series, we do tend to have a lower current. So now that I have my total current and my total voltage, I can do one of two things. I can find the power. Power we know is I times V. So that would be 0.46 times 25, which is 11.5 watts. Makes sense. Series connections tend to have a lower amount of power. Okay, so I could do that. So now I know how much power is running through the circuit. The other thing that I can do is now start to analyze the individual pieces of the circuit. So I'm going to erase my board, and then I'll start to analyze the individual pieces. Okay, so now we're ready to start looking at the individual pieces of this circuit. So we started with this big circuit. Fairly complex. When we go to analyze the individual pieces of it, we don't want to start with that circuit. We want to start with the smaller one and work our way back to that. So what I see when I look at this circuit is I see a 30 ohm resistor, which is real, and a 24 ohm resistor, which is made up of those two pieces. So I'm going to look at my real 30 ohm resistor first. This is connected in a series, and as we said, series current is constant. So that means that the current on that 30 is equal to the total current in my entire circuit. Since I know that, I can easily find what the voltage is. The voltage on the 30 is going to be I times R, or 0.46 times 30 ohms. Which is 13.8 volts. So that part of the circuit draws 13.8 volts of potential. Its power is again I times V, so 0.46 times 13.8. Which gives me 6.35 watts. Okay? Which, considering that we had 11.5 watts of total power, this resistor, this part of the circuit, is drawing more than half the power. Okay? And that should make sense because it's a 25-volt battery and it's drawing nearly 14 volts. So it is taking half of the voltage. That's something to consider. When we have a resistor in a series, the larger of the resistors is going to take the most potential. Okay. Now, you might want to pause it here, go back, look at what we've done, see if you have any questions. Okay? You can always feel free to text me. All right. Now let's get ready to analyze this 24. Because, yeah, I know it's a 40 and a 60, but I can't go to that portion yet. So I'm going to say, all right, this 24, I know what its current is. Its current is the same as what is on the 30, but its voltage is going to be 0.46 times 24, which is 11.0. Now, if I add 11 to 13.8, that gives me 24.8, which is very close to our 25-volt battery. Now I know the voltage that goes through that 24, but since that 24 is really a 40 and a 60 in parallel, I know that parallel V is constant. That means that the voltage on that 40 is 11, and the voltage on the 60 is 11. Now that I know its voltage, I can find its current. The current on the 40 is going to be 11 volts divided by 40 ohms, which is 0.28 amperes. And the current on the 60 will be 11 divided by 60, and that is 0.18 amperes. Kind of running out of room there. Now, if I want to check, I can 0.28 plus 0.18 That works out to be 0.46, which is what we said the total current running through that 24 should be. Now I can then find the power for each one of these. I don't have a lot of space here, but the power on the 40 is going to be 11 times 0.28, which is 3.1. And the power on the 60, 11 times 0.18, and that's 2. So now if I want to check my power, I can. I've got 2 plus 3.1 is 5.1. 5.1 plus 6.4, that's going to be 11.5, which is what my total power was. So we can see that, number one, circuits are great because they have many, many different ways that you can check your answer. And the other good thing about them is, I totally forgot what I was going to say. The other thing that I wanted to point out is if we compare this parallel, we could see that the higher resistor draws less power. Okay? All right. So I've lost track of what I was going to talk about after this, but we analyzed the circuit. If you have any questions, shoot me a remind, send me an email. Okay, look over the next set of problems that I'm pushing out on OneNote, and hopefully I will see you Monday. Make sure you wash your hands. Goodbye, AP Physics.